Hello girls, I hope you're staying safe at home. Now we move on to the next chapter in chemistry, that is electrolysis. Now electrolysis, as you can see, is made up of two words, that is electro and lysis. Electro means the flow of electrons or electricity, and lysis means separation. That is, a chemical change is brought about in a substance by the passage of electricity. So electrolysis shows a relationship between electrical energy and chemical change. Now, there are many substances which allow electricity to pass through them, and there are many substances which do not allow electricity to pass through them. It has also been found that all the substances allowing passage of electricity do not undergo chemical change. That means it allows electricity to flow through it, but it does not undergo any chemical change. Okay, so most metallic elements, metals like copper, aluminium, iron, and different types of alloys, whether in the solid state or in a molten state, molten means melted, allows an electric current to pass through them, but it does not go any chemical change. That is how we get electricity in our homes. We get current passes through the electrical wires made up of copper or aluminium, and the metal will remain the same. That means no chemical change is taking place. Okay, and non-metals except graphite, exception is very important, like sulfur, phosphorus, do not conduct electricity. So the only non-metal which conducts electricity is graphite. So metals and alloys are called conductors because they allow electricity to pass through them, and non-metals are called non-conductors or even insulators. Why? Because they do not allow electricity to pass through them. The conduction of current by a conductor is because of the flow of electrons. There is a flow of electrons through the conductor. That is why current passes through them. Okay, and insulators, they do not have any mobile electrons which move to carry the current. Okay, now when we talk about chemical compounds, we are not talking about metals or alloys now. Okay, so if you look at chemical compounds, you will see that they behave differently when an electric current is passed through them. Some compounds conduct electric current in an aqueous state when dissolved in water, or in molten state when it is melted, but not in the solid state. They will not pass electricity when in solid state. And these chemical substances becomes decomposed or breaks up by the passage of electric current. For example, the passage of, if you pass electric current through copper chloride solution, it decomposes to metallic copper and chlorine. So copper chloride is made up of copper and chlorine. So it separates. Okay, when electricity is passed through aqueous, that is in the liquid state, what happens? Copper and chlorine get separated. So this type of chemical compounds which conduct electric current in molten, melted, or aqueous state when dissolved in water are known as electrolytes. So remember, electrolytes do not conduct electric current when they are in solid form. Some compounds do not conduct electric current at all, whether they are in the solid state or in the liquid state or in molten state. So they are called non-electrolytes. Example, sugar solution. So when we define electrolysis, we define it as the process of decomposition of a chemical compound in aqueous or in molten state, accompanied by a chemical change by using direct electric current. And to define electrolytes, we define it as compounds which either in aqueous solution or in molten state. Most important, remember, the compound must be in aqueous solution, dissolved in water, or in molten state. So electrolytes are compounds with either in aqueous solution or in molten state allow electricity to pass through them or electric current to pass through them. Now electrolytes are molten salts, melted, or solutions of salts in water, dissolved in water, or solutions of acids and alkalis. As you know, acids and alkalis are liquid. Now, examples of electrolytes, we have acid, sulfuric acid, nitric acid, phosphoric acid, hydrochloric acid. Bases, we have sodium hydroxide, potassium hydroxide, ammonium hydroxide and calcium hydroxide. And salts, we have sodium chloride, copper sulfate and lead bromide. Remember, all of these must be in the melted state or in aqueous state, that is dissolved in water. Now, there are two types of electrolytes. Okay, they are either strong electrolytes which can conduct a lot of electricity and it can dissociate into ions completely, or a weak electrolyte which does not allow a lot of electricity to pass through it and it does not completely dissociate into ions. Okay, now next is non-electrolyte. So non-electrolyte is a compound which neither in solution nor in molten state allows an electric current to pass through it. So non-electrolyte is the compound which does not allow electric current to pass through it, whether it is in the melted state or whether it is dissolved in water. Okay, and it does not decompose, no chemical change takes place, so no decomposition will be seen at the electrodes. Okay, so non-electrolytes do not have ions. The ions are responsible for conducting electric current. Okay, so non-electrolytes do not have ions even in the solution form, so they will not be able to conduct electricity. Why? Because they contains only molecules. Examples of non-electrolytes, you have distilled water, alcohol, kerosene, carbon disulfide, cane sugar, benzene, glucose and urea. Now, acid, bases and salts as electrolytes. Acids and alkali ionize when dissolved in water. You know, they form ions. Whereas bases and salts dissociate in fused or molten, that is melted state, or in aqueous solution into free mobile ions. As I already told you, it is the ions which carry the electric current. So as I already told you, the electrolytes may be strong or weak depending on the degree of dissociation. Degree of dissociation means how many ions can be formed in solution or in the melted state. The more ions they can form, more current can be carried. So they are strong electrolytes. Less ions form means they'll be able to carry less current. So it is a weak electrolyte. In electrolysis, another thing you must remember is the electrolytic cell, also known as the voltmeter, which is defined as a non-conducting vessel containing two electrodes immersed in a solution of electrolytes used to bring about a chemical reaction. Now, this electrolytic cell or the voltmeter always needs an outside source of electricity, that is a direct current source. The direct current source of electricity which comes from outside helps to start the movement of ions between two electrodes. It is in the electrodes where the chemical change takes place. Remember, children, in a voltmeter, electrical energy is converted into chemical energy. So this is the voltmeter. This is the non-conducting vessel inside which you'll find the electrolyte, that is the compound which conducts electricity in molten or aqueous state. And then you have the cathode and the anode, which are the two electrodes. One, that is anode, is connected to the positive terminal of the battery. Remember, anode starts with an A, it means add. So it is connected to the positive terminal of the battery, that is the external source of electricity, and cathode is connected to the negative terminal of the battery. And here what happens is the current enters from the cathode and leaves from the anode. Okay, so migration of current is from cathode towards the anode. And remember, another thing is A to A and C to C. That means anions are negative. They will migrate towards the anode, which is the positive terminal. Remember, the opposites attract, okay, and similar repel. So C to C, cations are positive and they will move towards the negative electrode, that is the cathode. Okay, now next we come to the electrochemical cell, which is a device which is used to convert chemical energy into electrical energy. Simple voltaic cell, Daniel cell. Okay, example you can see in normal batteries. Chemical is inside the battery, and if you put it inside a torchlight, okay, current will flow and then the bulb will glow. So chemical energy is converting into electrical energy. And electrodes, as I already told you, they are made up of metals. Either they are metal plates or wires, graphite rods. Graphite is the only non-metal which conducts electricity, or gas carbon rods, which is immersed in the electrolyte, through which the current enters and leaves the electrolytic cells, and these are known as electrodes. Now, anode, I already told you, the electrode which is connected to the positive terminal of the battery, and cathode is the electrode connected to the negative terminal of the battery. Okay, and I already told you, when the current is turned on, the cathode is the negative electrode and electrons enter through the electrolyte, and the anode is the positive electrode by which electrons leave the electrolyte. Difference between cations and anions, you know, cations are positively charged ions and anions are negatively charged ions. They migrate towards the cathode during electrolysis, whereas anions migrate towards the anode during electrolysis. So what happens in the cathode is, cations, they gain electrons and gets reduced to become a neutral atom, whereas the anions lose electrons to the anode and gets oxidized to form a neutral atom. Okay, now that means, supposing sodium chloride is there, now during electrolysis it breaks up into sodium ion and chlorine ion. Now, how does sodium turn into sodium ion in sodium chloride? Because this is an ionic compound, an electrovalent compound. It is formed by the transfer of electrons. Okay, what had happened is, sodium had given away one electron to chlorine and it had become positively charged, and chlorine had gained one electron and had become negatively charged. So during electrolysis, what happens is, sodium, okay, which will migrate towards the cathode, and there it goes and gains the electron that it had lost. It will gain one electron it had lost and it will turn into a neutral sodium atom. And what will happen to the chlorine? The chlorine will migrate towards the anode, okay, it will lose the electron that it had gained, and then it will turn into a neutral chlorine atom. Okay, so that is what happens in the anode and the cathode. Now moving on to oxidation. Now in the electronic concept, I had already told you before also previously in the previous chapters that in the electronic concept, when an atom loses electrons, it becomes positively charged. Something positive is happening, so oxidation is taking place. So it is a process in which an atom or an ion loses electrons and becomes positively charged. Okay, or it turns into an atom. So here you can see zinc loses two electrons to become an ion. Similarly, sodium turns into iron, and iron turns into iron, and sulfur, when it loses two electrons that it had gained, it will turn into sulfur atom. And of course, you know, oxidation is also a chemical process where oxygen is added or hydrogen is removed. So here we have element carbon and oxygen. They combine together to form carbon dioxide. That means carbon has been oxidized. Similarly, magnesium and oxygen combine to form magnesium oxide. That means magnesium has been oxidized. So next we come to removal of hydrogen. In this equation, you can see how hydrogen sulfide loses hydrogen because of chlorine here, and sulfur is oxidized into sulfur. So here chlorine is the oxidizing agent and here oxygen is the oxidizing agent. So when we are talking about an oxidizing agent, we are talking about a substance which oxidizes other substances by either accepting electrons. In the case of sodium chloride, chlorine is the oxidizing agent. Why? Because it accepts electrons from sodium and turns sodium into positive charge. So sodium here has become oxidized and chlorine is the oxidizing agent. So here you can see the oxidizing agent is getting reduced. Okay, so when we talk about an oxidizing agent, it is an agent which oxidizes other substances by accepting electrons or by providing oxygen, or an electronegative ion, or by removing hydrogen, or an electropositive ion. Okay, so next examples of oxidizing agent solids, we have manganese dioxide, red lead, lead dioxide. Liquids, we have hydrogen peroxide, concentrated nitric acid, concentrated sulfuric acid, bromine. In gases, we have oxygen, ozone, chlorine, sulfur dioxide. Okay, now next we move on to reduction. Now in the electronic concept, reduction is the process in which an atom or an ion gains electrons. Okay, so gaining can be done in many ways. Copper atom can gain the electrons it had lost. Copper ions can gain the electrons it had lost and turn into copper atom. Okay, similarly iron ions can gain the electron it had lost. Okay, here remember, see, only one electron is being gained back, so it is turning into ferrous, ferric to ferrous. Similarly, tin ion will gain the two electrons it had lost to turn into an atom, a neutral atom of tin. Sulfur will gain two electrons and it will turn into a negative ion. So reduction in the electronic concept is a process in which an ion gains electrons. So it is gaining, addition of electrons. So reduction is also defined as a chemical process where there is removal of oxygen or addition of hydrogen, as you can see in these examples. An oxide with any element, you can see there is a displacement reaction, and how copper oxide loses the oxygen, undergoes reduction and turns into copper. Similarly, zinc here loses oxygen and turns into zinc. Okay, so in this case hydrogen and carbon are the reducing agents. Now addition of hydrogen, chlorine and hydrogen sulfide, sulfur and hydrogen chloride. So to chlorine, hydrogen is being added and the reducing agent is hydrogen sulfide. Similarly, to chlorine, ammonia is adding the hydrogen, okay, and chlorine is getting reduced. So what is the reducing agent here? Ammonia, and here the reducing agent is hydrogen sulfide. Now, reducing agent is one that reduces other substances by providing electrons or by providing hydrogen or an electropositive ion, or by removing hydrogen or an electronegative ion. So some examples of reducing agents we have in solids, we have carbon, metals like zinc, aluminum, copper, sodium, stannous chloride, glucose, okay, and in liquids we have hydrogen peroxide, hydrogen iodide and hydrogen bromide. Okay, now moving on to the gases reducing agent, we have hydrogen sulfide, carbon monoxide and sulfur dioxide. Okay, now theory of electrolytic dissociation. Svante Arrhenius in 1887 gave an ionic theory. So according to him, what he said is an electrolyte on dissolving in water, it turns into free mobile ions. That is, cations, positive ions, and anions, negative ions are formed, which allows the flow of electric current through it. And all ions carry an electric charge, and these ions are responsible for the flow of current through the solution, that is the electrolyte. Now, the conductivity of the electrolyte depends upon the concentration of ions in the solution. More the ions, more current can be carried. Less the ions, less current can be carried. So the number of positive charges equals the number of negative charges in the solution. When we're talking about the solution, we're talking about the electrolyte, and so the solution is in an electrolytic equilibrium. So when we talk about the solution being in electrolytic equilibrium, we are talking about the number of positive charges being equal to the number of negative charges. Okay, and this equilibrium is also between the unionized molecules. Some molecules will remain, supposing if you take some sodium chloride, put it in water, if all the sodium chloride will not be able to turn into ions, Na plus and Cl minus, some will remain as molecules, that is sodium chloride molecules. Okay, and this equilibrium is between the unionized molecules and also the ions produced. Now in non-electrolytes, that is the solution which does not conduct electricity, example, you know, sugar solution or benzene, there is no ionization. That means no ions will be formed. There are only molecules. Okay, so therefore that non-electrolyte will not conduct electricity. And the degree of dissociation is the extent to which an electrolyte dissociates or breaks up into ions. So the degree of dissociation means how many ions will be formed in the electrolyte after the electrolyte dissociates or it breaks down. Okay, now covalent compounds, you know, are formed by sharing of electrons, but covalent compounds which are polar in nature, that is which ionizes in solution. Okay, polar covalent compounds, you know, ionize in aqueous solution, they conduct electricity. Example, HCl, NH3, H2O, that is hydrochloric acid, ammonia and water, because these are covalent and they are polar in nature. Now characteristics of electrolysis. Now the passage of electricity through an electrolyte causes the positive ions, that is positive will migrate towards the cathode, C to C, and negative ions will migrate towards the anode, that is A to A. Anions will migrate towards the anode. Now the number of electrons gained by the anode is equal to the number of electrons given by the cathode. The cathode gives the lost electrons to the atom and turns it into neutral atom. So the products of electrolysis are formed at the anode and cathode itself. Remember, whatever products are formed, they are formed at the anode and the cathode itself, since the exchange of electrons takes place only at the surface of the electrodes. Remember that the main chemical reaction is taking place at the electrode, because the exchange of electrons, where does it take place? It takes place on the surface of the electrodes. Now only hydrogen gas and metals are liberated at the cathode. Remember, positive will move, cations will move towards the cathode, and you know hydrogen is positive and metals are all positive, so they will move towards the cathode. Okay, and they are liberated there, so they are known as electropositive elements. And only non-metals are liberated at the anode, so they are known as electronegative elements. Now the mass of substance produced at an electrode during an electrolysis is proportional to the quantity of electricity passing through the electrolyte. Remember, this is known as Faraday's law of electrolysis. Okay, so how much of substance, how much of the metal is produced at an electrode during electrolysis is always proportional, always equal to the quantity of electricity passing through the electrolyte. Okay, so if more electricity passes, then more of the metal can be produced. If less electricity passes, then less of the metal will be produced. Okay, now remember, the process of electrolysis is a redox reaction, that is reduction and oxidation takes place together. So you can see at the cathode there is reduction taking place as they gain electrons to become neutral atoms, while at the anode what happens? Oxidation of the anions is taking place because they lose electrons to become neutral. Okay, so here example you can see dissociation of sodium chloride. Okay, sodium chloride dissociates into Na plus and Cl minus, and at the cathode the sodium migrates C to C. Okay, it gains the electron that it had lost and turns into sodium. So here reduction is taking place, and at the anode what happens? Chlorine will give away the extra electron it had taken from sodium, and it will turn into chlorine atom, which is oxidation. And what happens? Two chlorine atoms will come together to form chlorine molecule or chlorine gas, a greenish yellow gas, which is liberated at the anode. Okay, so this is the overall reaction. Remember, I talked about direct current. Why? Because alternating current does not cause any chemical change when passed through an electrolyte, and it does not help in electrolysis to take place. And electrolysis is caused always by a direct current. So I will stop here today, children. Your assignment for this week is to write down all the definitions that you come across till wherever we have done, and draw the diagram of the voltmeter. Till then, children, stay safe. God bless you.